Hello, I welcome you all. The problem reads, starting from rest, a bicyclist travels around this horizontal circular path, rho equal to 10 meters at a speed of v equal to 0.09 t squared plus zero point 0.1 t meters per second, where t is in second. Determine the magnitudes of his velocity and acceleration when he has traveled 3 meters. Alright, this problem is coming from the Engineering Mechanics and Dynamics of 14th edition by R.C. Benam. A few basics, okay, before we draw what is happening. So our V itself is a time derivative of position. A acceleration is time derivative of velocity. From the two equations, we do have acceleration ds equal to v dv. Right, so from the three equations, we are able to derive a couple of equations depending on the boundary conditions. One of the most common equation is when acceleration is constant at t equal to 0. We do have additional boundary condition S naught and V naught. And from these three kinematic equations, we can derive these equations. S is equal to S naught plus V naught t half ACT squared, V equal to V naught plus ACT, and V squared equal to V naught squared plus 2AC S minus S naught. So let's draw what is happening here. This cyclist. So this cyclist is riding around a circular path. So let's imagine this is a path, and let's say we have let's say the rho itself, of course rho is given, so we've been told rho is equal to, so let's say rho, this is our rho, rho is equal to 10 meters, right? Did I say 10? So rho, which is the radius, is equal to 10 meters. And then let's say the cyclist, you've been told, rides a distance of 3 meters, right? Okay, this right, equal to 3, and we are being told at this particular point here we are supposed to find, let's say this is one component here for velocity, and then let's say we do have another component for acceleration in that same direction, and then another one at that point for acceleration in that direction. All right, and then we do have magnitude. Let's say this is the magnitude, right? So this is our A. This is AN, which is the normal or centripetal acceleration. This is tangential acceleration. And then we have our velocity, which is just VT. Alright, so let's say we want to find those values. Let me make this line a bit thicker. Maybe I make it thicker, so let me go through it again. So this is the path. Okay. Right. So what do we do? So let's write down what we have. So our V, this V is equal to Vt, okay, and it's equal to 0.09 t squared plus 0.1 t, and t is in seconds. And then we do have rho, of course, rho is equal to 10 meters. Alright, so let me just remove this. So from this, we are able to determine AT, okay, and then later on the important thing that we'll need here is the time. Once we have the time, then we can calculate the actual number. Okay, so let's find the time. So use this equation there. So we have V equal to we have v equal to ds dt, and writing this just becomes v dt equal to ds, and we are integrating this from 0 to t, starting from rest, and also s will be s to s. Alright, and our s here is equal to 3. Okay, so let's write it down now. So we have I write down the actual function 0.09 t squared plus 0.01 t dt, integrating from 0 to t. Then this is just going to be equal to from 0 to 3 ds. So this becomes a 0.09 t to the power 3 divided by 3, okay, plus 0.1 t to the power 2 divided by 2, and then this is just going to be equal to a 3. Alright, okay, so simplifying this, let's divide it by 6 to factor it out. Divide it by 6, so this will become that's a 2 by that one there, that's 0.18, right, t cubed plus 3 by that 1.3 t squared, and later on a 6 by that 18. Then I bring it that side, then I have this. So let's write this as a function of t. I have something like so. Alright, okay, so my t here, my domain here, my t, I'm just interested in positive values. I know I'll have 3 values of t because the highest power is 3. I'm just interested in the positive ones. So this would be my domain. I want to use the trial and error method, which is a numerical technique. Okay, we have negatives, positives. The idea is we find the value of t that gives us a negative, the other one a positive, then we know to say the solution lies in between, and we start iterating. Okay, so let's do that. Of course, you can solve this however you feel is okay. For me, I'm using this numerical technique that I've always been using. So let's say we have a t there, and then here I have my f of t, which is more or less like an error. Okay, as the error reduces, as it gets closer to 0, then I know to say at least my solution is slowly converging to the exact solution. So when my t is 0, let me plug in this equation in advance in my calculator. T squared times 0 to the power 3, okay, plus 0.3 times 0 to the power 3, 2, minus 18 to the power 2, okay, minus 18. So this one of course just gives us 18, right? Let's go to a 2, push in a 2, let's see where we get to. So 2 there, and a 2 there. Alright, so this still is a negative 15.36. Let's put 8. We jump to 8. The idea is we need to find a positive value, then we know the solution is somewhere. We already have a negative, so we put an 8 there, and another 8. Right, so we have a 93.36. You can think of these as errors. So now we have a positive value, this one and this one, you see. So it means the solution lies somewhere between one of the solutions. Like we said, we have 3 solutions because the power is the power 3. So we have the solution between 2 and 10. 2 and 8. So let's now do the iteration between 2 and 8 to add them, get the average. So 2 plus 8, 10 divided by 2, 5. Let's plug in a 5. We have a 5 there. We have 5, so we get a 12. Okay, again, there we go, between 2 and 5. So the idea is we always go to the smallest values of negative and positive. So we have a 3.5, 3.5, 3.5, and also 3.5. Okay, what do we get? We have a negative 6.61. Solution is somewhere between 5 and 3.5, average of the two. Let me get another device for getting these averages because I already have the formula in my phone. Okay, sorry. Where is my calculator? Here. All right. So here it is a 5 plus 3.5 divided by 2. So we have a 4.25. Let's plug in a 4.25, a 4.25, 4.25, 4.25. All right. So slowly it is reducing. We have a 1.24. The error is reducing. So the solution is somewhere between 3.5 and 4.25. So let's get the average of this. Plus 3.5 divided by 2. So we have 3.88. Let's plug in that value there. 3.888. Okay, 3.888. What do we get? We have a minus 2.97. So the solution is between 4.25 and 3.88. So slowly we are converging as we are doing this iteration. 3.88 plus 4.25 divided by 2. So we have a 4.07. Let's get that one. 4.07. 4.07. Right, so we have a 0.90. The smallest positive and negative is this number, and the other one again we are always going to the smallest one with the smallest, so it's a 4.25 and 4.07. 4.07 plus 4.25 divided by 2, so we have a 4.16. Let's plug in that one, 16, and also the other side 16. So this becomes a 0.15. The solution is somewhere between the two. That's 4.07 and 416. 416 plus 4.07 divided by 2. So this gives us a 4.12. A 4.12. Alright, so this gives us a 0.32. The solution is somewhere between the two. So 4.12 plus 4.116 divided by 2. This is a 4.114. Let's plug in that. Okay, minus 0.09. The error keeps on reducing. Again, these are the smallest positive and negative. 416 and 414. So plus 416 divided by 2, 415. Alright, let's plug in this one. 15 there and 15. Of course, we have a 0.03. Alright, so solution is somewhere in between these two. Of course, this is so far the lowest. So if we are to try this again, if you are to go in between this, you're going to have something like this, 4.145. Okay, let's try that one. 145. Okay, so this one becomes a minus 0.0 3, but here it goes to 2, maybe 7, somewhere there, like so. All right, if we round it off, it comes to this. Okay, so I'll pick this one here. I'll pick this one because when we round it off with 2 decimal places, it gets to the same value. Right, so our t is approximately equal to 4.15 seconds. Okay, so with this time, we can use this time to compute the values of velocity as well as acceleration. So let's find the acceleration and then later on we calculate. So we know that our acceleration itself is time derivative of velocity, and this is just equal to our velocity is 0.9 t squared plus 0.1 t. Okay, with respect to the t. So if we work this just gives us a 0.18 t plus 0.1. Okay, and then t a at t equal to 4.15, and we get 0.18 times 0.18 times 4.15 plus 0.1. So this just gives us a 0.8470. Okay, 4.15 by 0.18 plus 0.1847. Right, then we have our velocity, which is equal to vt, which is equal to this is also vt here, which is equal to 0.09. Okay, 0.09 t plus 0.1 t, and our vt itself at t equal to 4.15, this is just going to be equal to 0.09 times 4.15 squared plus 0.1 by 4.15. So this we get a 1.97. Okay, so this one is okay. So then we have an, I wanted to put units there, we have an and vt squared divided by rho, which is just equal to 1.97 squared divided by our rho is 10. So this we get 1.97 squared divided by 10. So we have a 0.3881, and therefore the magnitude is just equal to square root of at squared plus an squared. Therefore our n is just equal to 0.3881 squared plus a itself, which is just 80. This is 80. Okay, this is 80. Right, is 80, so plus 0.8470 squared, and square root of that. In our A, the magnitude is just 0.9317, and the units are in meters per second square. And our V is just equal to Vt, which is equal to 1.97 meters per second. So found velocity and acceleration when the cyclist travels S is equal to 3 meters. So I think this is about it, and I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my video. Bye bye, and I'll see you in my next screencast. I just want to make mention to say we also used this particular equation. All right, bye bye.